Hello, student. So this will be our first proper lecture. Okay. Uh, so already we have discussed uh, something related with the automation. Okay. Uh, so we have discussed how to design a very simple automation system using sensors, actuators, and some controller, electronics controller. Okay, so we will see those things again. So this will be your first lecture. Okay, others are just the class discussion. Okay, so so your exam will be mostly based on these lectures. Okay, so you have to properly go through these lectures. Okay, so we have I think you have already have idea what is automation. Okay, we have discussed these things. Okay, so what is automation? Automation means actually it is come from automatic, no? Automatic. Okay, so what is automatic? Automatic means self-acting. Self-acting or self-operation, okay, of a machine, or uh, maybe a unliving thing. Okay, okay, most probably it will be a machine, self-acting machine. Okay, so that is automatic. For example, if you say automatic car, that means if you given the instruction to the car, go to this place, okay, go to any specific place, the car will go there by itself, okay, without a driver. So that is automatic car. Okay, so there is no the people or human didn't interact with that operation, no. Okay, so that is actually automation. Automation means we can say that it is not, it may be not a proper definition. Okay, but we can say that uh, uh, if we can done, if we can get done a work without human interaction or very low human interaction, okay, get done a job, any work, okay, without human interaction or maybe human labor, okay, or with very little labor, with very little human interaction, okay, human interaction, uh, so that is the automation. Okay, so that is the automation. Okay, so for example, I think we know that if we have woods and if we have the uh, uh, required skills, necessary skills, we can make a toy using that woods. Okay, so that is a manual process. Okay, that wood is done by that work is done by us, done by people, so that is a manual process. Okay, and you know that there are some machines are there. Okay, some machines are there. If we put the required material, okay, so that work can be done automatically. Okay, so that is actually automation. Okay, okay, so so if I show you a video, okay, just give me a moment. Okay, so we will see. Uh, so I will show you a manual process. Okay, that is done by some peoples, maybe rice harvesting. Rice harvesting, I think you have already seen these things. Rice harvesting by hand. By hand, yeah. Okay, so we can see some, yeah. So, so here, I think you can see the, so this is, I think, some automation system. I don't know what is that. Anyway, we skip. Okay. Okay. Actually, here it is not. Yeah, like this, you can cut the rice tray by your hand. Okay. Then manually you can clean them and you can get the rice. Okay. So that is a manual process. Okay. So, but if we see, okay, so you can see also some rice harvest machine. Yeah, maybe machine. Let's see. Okay, okay, we see here. So this is a machine. Okay. So you can see that I think I can't see. Maybe it is driven by a, yeah, it is driven by a human, but you can see the rice uh, are being cut, okay, and cleaned by itself, no, by the machine, okay. So you can see that here the human interaction, the humans are doing some work, okay, but their works is very low, okay. The most work is handled by or done by the machine, okay. So that is actually automation. Okay, someone can say that this is not automation. Okay, this is not fully automated system because there should be a person who should drive this machine. Okay, someone can tell like that. Okay, so that may be also true. Okay, but this is actually automated system up to some level. Okay. uh, okay, so I think you get the idea. Okay, and if I go to, yeah. Okay, and so you can see that mm, there in automated system, human interaction is very little. Okay, human interaction is very little. Okay, and another terms we have learned, that is mechanization. No, mechanization. Okay, so what is mechanization actually? Mechanization means uh, we use tool. Okay, we can use tool. Okay, the human normally use tool. Okay, use tool or machine, actually use tool or machine to to get the help, to get the help, or to make our work easy, to make our to make their work easy using these tools. Okay, for example, if man has a grinder and he need to cut something, okay, he can use a grinder. Okay, but the main thing is done by the man, not the machine. Okay, so that kind of thing is mechanization, not the automation. Okay, so I think mm, if you have a general idea about this automation and what is automation and what is mechanization, that will be enough. Okay, uh, so try to read your reference books. Your reference book is also there. Okay, so you can get more information. Okay, and mm, uh, and also importantly, there may be some advantage and disadvantage using the automated system. Okay, if we think in the environment side, okay, so maybe automation will direct to pollute our environment. Okay, so that may be a disadvantage. Okay, uh, and also there are some advantage. Okay, so I think you can search them by yourself by reading the reference book. Okay, those are somewhat those are also important when you are learning this automation, when you are learning about this automation system. Okay, and okay, now we will move to our next section. Okay, and actually we have done these things. Okay, so we have designed. Okay, we have already designed. Okay, not completely, but up to some level we have already designed some systems. Okay, some automation system using some equipment. Okay, we have discussed those things in our class discussion. Okay, so for that, okay, before that I should tell you that there may be many automated system. Okay, there may be many automation system. Okay, so someone may be hydraulic system. Okay, hydraulic system. Okay, so that is controlled by fluids. Okay, fluids. Okay, fluids of water. So those are hydraulic system, and maybe there are maybe pneumatic system. Okay, pneumatic system. Okay, normally gas are involved in controlling the systems. Okay, and there may be mechanical system. Okay, mechanical system. Okay, so there may be many automation system. Okay, but but uh, but this day, okay, but present, okay, at present, most of uh, control, the most of the controlling part, okay, most of the controlling part is handled by most of the controlling part is handled by electronics systems. Okay, electronics or electrical system. Okay, electrical systems. Okay, so in this course we will focus our attention only to electronics and electrical automation system, automated system. Okay, we are not going to study the other system. Okay, but in your reference book those some informations are there. Okay, so if you are interested, you can read them. Okay, but in this course we will mainly focus our uh, attention to electronics and electrical controlling and automation. Okay, so when we are talking electrical automation, okay, electronics automation, electronic or electrical automation, actually we can't do the automation only with the electronics and electricals. Okay, we need some mechanical equipment also, mechanical equipments also. Okay, so we can say that maybe our focus, okay, maybe our study, okay, our study mainly focus on mechanical and electrical system. Okay, mechanical, electronics and electrical systems. Okay, we can say like that. Okay, because sometimes mechanical parts also we have to involve in our systems. Okay. So when we are talking this automated system, okay, we have seen that we have to use some components. Okay. We have to use some component. Okay, we have already discussed these things in our classroom. Okay, so one thing is sensors. Okay, one thing is sensors. So we are using sensors. Okay, actually we are using sensors to get input data. Input data. Okay, and so already we have discussed about some sensors. Okay, not discuss, we just talk about some sensors. Okay, temperature sensors. Okay, temperature sensor, IR sensor. Okay, I think you can remember maybe. IR means infrared sensor. Okay, we have used this infrared sensor to control a door. I think you can remember. Okay, and we also talk about some optical sensors, photodiode likewise. Okay. So sensors, we have talked about sensors, and we have talked about actuators. Actuators. Okay. So what is actuators? Actually, actuators we use to have output, no? To give output based on this sensor information. Okay, actuators we use. Okay, example for actuators are motors. Okay, and we have used AC machine. Okay, heater. I think you can remember that. Okay, in the case of door controlling, actuator is motor. Okay, and we have also discussed the temperature control system. The actuators are AC and heaters. Okay, and also we have talked about relays. Okay, relays also we can consider as actuators. Okay, and the other main part is controller. Okay, controller, and normally we have used electronics controller. Electronic controller. Okay, controller to control these things. Okay, and mm, and sometimes we need a memory also. With this controller we need a memory. Okay, memory, uh, and we can make a simple automated system. uh, we have already designed some simple automation system with these devices, no? Sensors, actuators, and electronics control. Okay, so now we will talk about these things up to some level. Okay, so if you consider a sensor, okay, if you consider a sensor, okay, so you already know what is sensor. Okay, sensor, actually sensor is a device. Okay, it is a device that convert any physical parameter, physical quantity or parameter into a electrical mean. Okay, electrical mean. Okay, electrical means it may be a voltage or it may be a current. Okay, or it may be a resistance or something. Okay, but again using that resistance, we again need the voltage and current to measure. Okay, so we can say that sensor, okay, sensor is a device that convert a physical parameter. Physical parameter means temperature. Okay, temperature, may be sound. Okay, may be light, anything. Okay, any physical quantity. Okay, any physical thing. Okay, into electrical mean. Okay, so that is a sensor. Okay, so so it is actually converting one quantity into another quantity, no? One variable into another variable. Okay, so that is also called as transducers. We have already told this. Okay, so we can say that the sensors are transducers because it is converting uh, one energy or something into another energy. Actually, electrical means, okay, voltage or current. Okay, and sensors we used to get the input to the system. Okay, so sensors are input transducers actually. Okay, sensors are actually input transducers. Okay. Uh, okay, so that is the definition for the sensor. That is the description for the sensor, maybe not the definition. Okay, so if you need to know a proper definition, you can check your reference book or you can check the internet. Okay, but I think better thing is you should have the idea. Okay, you should have the idea about these things. Okay, that will be enough. Okay. So if we are talking about sensor, okay, sensor, there are many specification related with sensor. Okay, so we can say that they are sensor specification. Okay, sensor specification. Okay, there are many specification with sensor. Okay, so one thing is sensitivity. Sensitivity. Okay, and the sensitivity means uh, actually it is it tell us the change, okay, change of the output, okay, change of the output uh, according to the input change, according to the input change. Okay, for example, say you have a temperature sensor. Okay, so that temperature will give a good output, good voltage. Okay, the proper voltage, enough voltage for very small change in the temperature. For example, uh, if it is 0.01 Celsius degree, if you are given a understandable uh, change in the output, okay, measurable change in the output, okay, so that is we can say that that temperature has a good sensitivity. Okay, um, I will explain it. Okay, for example, say that, okay, say that you have a temperature sensor. Okay, so you already have seen a temperature sensor, no? It is like that. You have two terminal. Okay, you have two terminal. Okay, and we have fixed this to a meter. Okay, and you can see that we can see some if we change the temperature, we can see some values here. Okay, temperature value here. Okay, so say that now it is 25 Celsius. Okay, and we have a value here. Okay, maybe say that it is a voltage. Okay, so for 25, maybe let's say that 5 volt it show us. Okay, say that now now the temperature is 20.5 or something. Okay, at that time, if you are given a considerable voltage difference, say that 5.1 volt. Okay, so you can see that it is measurable, no? It is somewhat uh, considerable voltage difference. Okay, for this very little temperature difference. Okay, so that you can say that this has a good sensitivity. Okay, so sometime maybe 25 up to 40. Okay, maybe 40. If it is not given a good value, maybe 5.5 volt, 5.6 volt. Okay, so you can say that the sensitivity is very low. Okay, actually our actually we have checked our temperature sensor. What can you say about our temperature sensor? We have checked in our class discussion. It is actually have a low sensitivity, no? Okay, when we try to increase the temperature, it will not give a proper output. Okay, so you can say that the sensitivity is very low. Okay, so that is the sensitivity. That is important parameter, is important specification of the sensor. Okay, and the another specification is the range. Okay, I think you know what is the range. Okay, so any sensor has a specific range actually. For example, maybe if you have a temperature sensor, we can measure the temperature only between uh, 10 Celsius and 45 Celsius. Okay, so within this range only we can get the output. Okay, so if it is more than 45 Celsius, maybe the sensor will be damaged. Okay, so that is the range. Range means the difference between minimum and maximum value that can be measured by the sensor. No? Okay, so that is the range. So this is the minimum value and this is the maximum value. Okay, so difference between maximum and minimum value. So here you have 35 Celsius. Okay, okay. So this will be the range. This will be the range of the temperature sensor. Okay, so you can say that the range is between 10 Celsius and 45 Celsius. Okay, so that is the range. Okay, and another specification is resolution. Okay, resolution. Resolution means that is also related with the sensitivity, but it is not the sensitivity. Okay, uh, resolution means the small difference that can be catched by the sensor. Smallest the physical parameter difference that can be catched by the sensor. Okay, so you can say that is smallest difference in the input. Okay, in smallest difference in the input that can be uh, catch or that can be measured by the sensor. Okay, for example, if we are talking, if we take the same temperature sensor, maybe uh, it can detect only maybe zero point 0.2 Celsius. Okay, so if it is less than 0.1 zero point 0.2 Celsius, that cannot be detected by the sensor. Okay, okay, so if I give you some value, okay, so say that we have 25 Celsius. Okay, so sensor can detect it. Okay, and say that uh, if the if the temperature is 20.5, okay, 20.5, okay, 20.5, that is also can detect by the sensor. Okay, 20.5. Okay, but if it is 20.1, it cannot be detected because the smallest difference should be zero point 0.2. Okay, so if it is 20 Celsius and 25.2 Celsius, it can be detected, but less than 20, if the difference is less than zero point 0.2, it cannot be measured by the sensor. Okay, so that is the resolution. Okay, I hope you have understand what I'm talking. So if you can't understand, please ask me again, then I will again explain. Okay. Uh, so that is another specification. Okay, likewise there are many specification available actually. Okay, but we no need to consider all the things. Okay, so there are many specification, precision, okay, and the accuracy, okay, and what else? The so there are many. I can't remember all the things, but there are many important specifications are also there. Okay, but what I want to tell you is that if you uh, uh, the sensor have this kind of specification. Okay, so if you are choosing a sensor for a specific task, okay, you have to pay the attention on this specification based on your requirement. Okay, so that is the idea you should get. Okay, so okay, so those are the sensor specification. And also I want to tell you that we have already discussed these things. Okay, so we have discussed these things. Okay, uh, the output of the sensor. Okay, output of the sensor. Okay, output of the sensor may be analog output, may be analog output, or it may be a digital output. Okay, so I think you can remember that we have talked this digital output. Okay, so sensor output can be analog or digital. I think you should know about what is analog. Okay, analog output, or let's say that analog signal. Okay, and what is digital signal. Okay, I have explained this in the classroom. Okay, so analog signal means, okay, if the so it is actually mainly depend on the magnitude or amplitude of the signal. Okay, it is not depend on the time. Okay, it is depend on the analog and digital, depend on the amplitude of the signal. Okay, uh, okay, uh, in some books this is different. Okay, but this is my understanding. Okay, so I think that will be enough for you also. Okay, analog means you can have many amplitudes value. Okay, so I already told you that sensor will give the output will be a electrical mean. No? Output will be a electrical mean. That means it will be a voltage. Okay, it may be a voltage or it may be a current, most probably. Okay, it may be a voltage or it may be a current. Okay, so if the output voltage or current of a sensor, okay, has several amplitude level like this. Okay, several amplitude level like this. Okay, so you can see that there are maximum and minimum value. Okay, maybe this is the maximum value and this will be the minimum value. Okay, but this maximum and minimum, you can see that there are many values, many levels. Okay, so these levels you can't count. Okay, there are infinite number of levels. Okay, so here you have seen that infinite number of levels. Okay, for example, if your sensor will give you a voltage between 5 volt and plus 5 volt. Okay, according to the input variation, according to the physical quantity variation. Okay, so you can see that between -5 and 5 there may be infinite number of level, including the decimal value. But if you are asked to count the only the integer, that means -5, -4, -3, -2, -1, 0, 1, 2, 3, 5. So you have the countable value 1, 2, 3, 4, 5, 6, 7, like that. You can count this value, number of value 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 9. Okay, 10, no? Okay, so there are 10 values. Okay, so you can count them. But this is not integer. Okay, between these value, not integer. The decimal values are there. Okay, so decimal value can be in any decimal places. Okay, so you can't count the value between plus minus 5 and plus 5. There are infinite number of values. Okay, so I have explained this in the classroom also, so I think you can understand. Okay, just to refresh your mind. Okay, just to refresh your memory. Okay, so those are the analog signals. Okay, the analog signal means, or analog input output means the output level. Okay, output levels should be infinite. Output levels are uncountable or infinite. Okay, so that is analog output. Okay, output levels, if the output levels are uncountable. Okay, output level output level uncountable. Uncountable, that means we can't count them, or infinite, levels are infinite. That is analog signal. And what is the digital signals? If the output levels are countable or few outputs level, that is a digital system, digital output. Okay, that maybe the output value may be 2. Okay, it may be 5 volt and only 0 volt. Okay, so you have 5 and 0 only. Okay, so you can see that you can count them, only two values. Okay, and maybe uh, 3 or 4 values. Okay, maybe 5 volt, maybe 4 volt, maybe 0, maybe minus 5, maybe plus 5. That means you have very few countable values. Okay, only 4 voltage levels. Okay, only 4 output levels. Okay, so those are digital. Okay, actually most probably digital signals will have only two levels. Okay, only two levels. Okay, so that you can name them with 0 and 1s. Okay, that is why a digital system normally named or normally represent using zeros and ones. No, okay, for example, this 5 can be represented as 1 or 0. Okay, and this 0 can be represented as 1 or 0. If the 5 is represented with 0, you can represent 0 with 1, or you can change this 5 from 1 and 0 from 0 itself. Okay, so this is a digital output. Okay, only few levels are there. Okay, okay, so that is so what you have to know is that sensor have both analog and digital outputs. That is the idea you should take. Okay, and also you should know what is analog output and what is digital outputs. Okay, okay, so I think it is clear for you. Okay. Mm, then we have to talk about some types of sensors. Okay, some types of sensors. Types of sensors. Okay, we have to talk some type of sensors. Okay, so there are many types of sensors, but for our study, I think we have if we consider only 3 or 4 types of sensor, I think it will be enough. Okay, uh, so sensors can be classified. Okay, this is classified. Sensor can be classified. Okay, classified based on their detected quantity or detected energy. Okay, the the measurable energy. Okay, so those are the type of sensors. Okay, for example, uh, we have some thermal energy, thermal sensors. Thermal sensors. Okay, thermal sensors means uh, it can detect. Okay, it can detect thermal energy, only thermal energy. Okay. So these are thermal sensors. Okay, it can detect thermal energy. Okay, so these sensors are classified based on their detected energy actually. Okay, so we can say that we have thermal sensor. Okay, that is the thermal energy can be detected by those sensors. Okay, example for thermal sensors are temperature sensor, and uh, heat sensor, maybe heat sensor. Okay, so there are many types of sensors. Okay, there are many examples for thermal energy sensors or thermal sensors. Okay, so this can be achieved in any means. Okay, the one means is we can use a thermistor. Okay, thermistor. Okay, actually this is thermistor means thermal resistor. Thermal thermal resistor. Okay, thermal resistor. That means this resistor, the resistivity of this, it is actually material conductor. Okay, we are using a metal conductor. Okay, metal material. Okay, so the resistance will be changed with respect to the heat temperature. Okay, so that is we call thermistor. Okay, so using thermistor, you can design or you can implement a thermal sensor. Okay, so there are many things. Okay, and we have thermocouplers. Okay, uh, so if you need more information, you can search them. Okay, how to implement thermal sensor. So there are many means. Okay, one example is thermistor. Okay, using the thermistor, you can implement a sensor. Thermistor is nothing but it is a variable resistor. The resistance will be will be varying according to the temperature. Okay, so that is the thermistor. Okay, and so those are the thermal sensors. Okay. Okay. So actually these are only for information. Okay, you no need to remember. Okay, but you have to idea. You have to have idea how these sensors, how we can get these sensors. Okay, what are the material we can use. Okay, so that idea you should have. That is why I am talking. Okay. Okay, so other type of sensors are we can say that mm, electromagnetic sensors. Okay, electromagnetic sensors. Okay, so it sends the electromagnetic energy. Okay, it sends the electromagnetic energy. Actually, examples are I have shown you a multimeter. Okay, in that multimeter there is a voltmeter, there is a ammeter. The voltmeter is measuring the voltage, ammeter is measuring the current. Those are measured using the electromagnetic energy. Okay, so those are electromagnetic sensors actually. Okay, uh, so those are electromagnetic sensors. Okay, and we have radiation sensors. Okay. Okay, so examples are uh, uh, we can say that optical sensors. Okay, optical sensors. Okay, and uh, what is IR sensors? Okay, IR sensors. Okay, so those type of sensors are radiation sensor. It measures some radiations. Okay, so optical sensor will measure a light. Okay, light also electromagnetic wave, radiated electromagnetic wave. Okay, so you can you so we can say that optical sensor is a radiation sensor. Okay, and IR you already we have discussed these things. Okay, infrared sensor. Okay, that is also this type of sensor. Okay, and uh, So example for optical sensors are photodiode. That is the very popular example for optical sensor, photodiode. Okay, actually it is a diode, just a diode. Okay, if a light, uh, if the light incident, okay, if any light is incident on that diode, the current will be generated. Okay, so those are optical sensors. And also we have uh, uh, LDR. Okay, that means light dependent resistor. That is also a resistor like thermistor. Okay, so the resistor will be changed according to the light. Okay, okay, so those are optical sensors. Okay, and we have IR sensor also. Okay, so there's a radiated sensor. And I think the other part is mechanical sensor. Okay, mechanical sensors. Okay, so there are many type of mechanical sensors. Okay, for example, there may be acoustic sensors. Acoustic sensors, we have talked about these also. Okay, example for acoustic means sound. Okay, our voice, our sound, our hearing sound. Okay, so the microphone is acoustic sensor. Microphone, what is microphone doing? It convert our voice into electrical signal. No, our voice into electrical signal. Okay, so that is also a sensor transducer. Okay, we used it as an input transducer, no, as an input data. Okay, so that is the input transducer or sensor. Okay, and so uh, and also there are some sound sensors also there. Okay, ultrasonic sensors likewise. Okay, I'm not sure the ultrasonic sensor may be not included in the acoustic sensor because it is not in the hearing range. Okay, so I'm not sure, but you can search that one. Okay, anyway, the microphone is a acoustic sensor. Okay, that is come under mechanical sensor. Okay, and you have pressure sensor. Okay, pressure sensor, you can measure the pressure of something. Okay, pressure of the water, pressure of any device or something. Okay, so you can measure them. Okay, and also you have water sensor. Okay, water sensor, that is also a mechanical sensor. Okay, or we sometimes called it flood sensor. Okay, and gas sensor, smoke sensor. Okay, smoke sensor or gas sensor. Okay, gas or smoke sensor, those are mechanical sensor. Okay, and fire sensor, so those are normally mechanical sensors. Okay, uh, so I think that is enough. If you have the idea about these type of sensors: thermal sensor, electromagnetic sensor, radiation sensor, and mechanical sensors. Okay, uh, so this type of sensors you can find. Okay, so there are many other types. Okay, uh, okay, so these are some type of sensors. Okay, so I think that is enough to talk about sensors. Okay, so we have talked here what are the sensor, what is the sensor. Okay, sensor is an input transducer. Okay, and we have discussed about sensor specification, some sensor specification. Okay, those specification we should use when we are choosing a sensor for a specific task. Okay, and there are many type of sensors that the type will be depend on the energy the sensor can be detected. Okay, energy can be detected by the sensor. Okay, and also we can say that sensor can have two types of output: the analog output or digital output. Okay, so I think that is enough about sensors. Okay, next we have to talk about actuators. Okay, actuators. Okay, I think you already know what is actuators. Okay, so actuators we use to do a work, to give a to give output. Okay, actuators we use to give output. Okay, to give output. Okay, for examples for actuators are motor, relay. Okay, many lever system. Okay, heater, air condition. Okay, so those are the example for actuators. Okay, so you can say that if you consider a motor, you have to give an electrical signal to a motor, then it will be rotate. Okay, so this you have the electrical energy, and here you have a rotating, no, we called it kinetic energy. Okay, so it is converted to output form. Okay, so this is also a transducer. We can say that actuators are output transducers. Okay, the actuators are output transducers. Output transducers. Okay, so this is the these are the output device actually. Okay, for example, speaker. Another example is speaker. Speaker also output device, no? If you give a electrical signal, okay, the speaker will generate a voice. Okay, so you can see that here you have electrical energy. Okay, you have electrical energy, it converted to a sound, another energy. Okay, so it is a transducer also, but it give output. Okay, not the input. So you can say that it is a output transducer actuators. Okay, so there are many actuators. Okay, and there are many specification related with the actuators. Okay, uh, so I think you already have that idea. That is normally a common sense. Okay, so I think that may be enough. Okay, so other thing is the controller part. Okay, so I already told you that for controlling we are normally use electronics circuits or electronics device. Okay, in this day. Okay, controlling controller. Okay, at present we are normally use electronic device. Okay, electronic device, maybe a computer, maybe a computer, maybe a microcontroller. Okay, microcontroller or processor. Okay, so any device. Okay, any electronics device. Okay, so so we have already discussed about digital processors. Okay, digital processor. Okay, okay, so processor means it can perform some kind of function. Okay, controlling and uh, calculation function maybe. Okay, so that is a processor. Okay, so so you know that in your computer there is a processor, no? We called it CPU, central processing unit. Okay, so that is the main part of the computer. Okay, so there are many type of processors. Okay, uh, so so these processors are mainly based on, okay, these are designed actually using the building blocks of this processor. The modern processors is the transistor. Okay, transistor, you know the transistor, it is an electronic device. Okay, so using transistors we have developed some processors. Okay, and if you consider processor, there should be at least three parts. Okay, one is the control unit. Another is the arithmetic and logic unit. Arithmetic and logic unit. Okay, logic unit. Another is the registers. Okay, registers. Okay, so processor should have at least these three type of subunits in it to do the performance. Okay, the control unit means is control the operation of the processor and control the input and output. Okay, and arithmetic and logic circuit will perform the mathematics and logic function. Okay, registers are actually, this is a memory. Okay, these are temporary memory location, temporary memory location. Okay, memory location that need to, that used to store temporary data. Okay, to process. Okay, processing data and process data also. Okay, should be stored for some time. Okay, so we are, so for that purpose the processor use registers or temporary memory location, temporary memory location. Okay, so digital processor should have at least these three parts. Okay, okay, and also so you can use a processor as a controller. Okay, you can use a processor as a controller. Okay, and also you can use a microcontroller. Okay, so microcontroller is actually processor, it is also a processor, and there is a memory also. Okay, memory also, and you have the input and output pins. Okay, so microcontroller is just like a small computer actually. It is a chip. Okay, it is a chip. I have showed you, no? In Arduino board, in the middle, you can see the microcontroller, Atmega microcontroller. Okay, so that is a processing unit, actually processor plus memory. Okay, so so you can use a microcontroller. Okay, so so microcontroller processor, you can program. Okay, you can give instruction to the microcontroller processor to get done a specific task. Okay, i have I have explained it. Okay, so there is a, so I have shown you Arduino board. Okay, so that is actually a microcontroller board. Okay, you have the microcontroller here, and you have the interfaces here, like this. Okay, okay, and you can connect this chip to a, to your machine, to your laptop or computer. Okay, using a programmer. Okay, so you need a special interface device called programmer. Okay, but for Arduino, we no need a programmer because the programmer is already installed in this Arduino. Okay, so we have that USB interface. Okay, so for when we are programming the Arduino board, we don't need a programmer, separate programmer. The programmer is inbuilt in it. Okay, so you can connect it with the computer and you can code it and send the, store the instruction here. So it will work according to instruction. Okay, okay, and also you can use a computer. You can use a computer to control the system. Okay, to control the system. Okay, so you can use a complete computer. Okay, so as a controller, you can use a digital processor, microcontroller, computer. Okay, so that is the idea you should take. Okay, so I think we have discussed the main part of a controller system, not a controller system, automation systems. Okay, system. Okay, sensors, actuators, and the controller. Okay, so I think I have in our classroom, I have talked about relays. Okay, I have talked about relays. Okay, please refresh that memory also, relays. Okay, so there can be a mechanical relays are there. Mechanical relays. Mechanical relays means we have moving parts, no? We have moving parts. Okay, and we have static relays. Okay, static relays. Static relays. Normally, we use transistor. transistor to make these static relays. Okay, so it doesn't have moving parts. Okay, so these type of relays we can find. Okay, I have so that is the idea you should take. The relays can be implemented using transistor, static relays, or with the mechanical part with electromagnetic functions. Okay, so I have told you that how to implement a relay very simply. Okay, so I think if you can remember that, if you have a conductor like this. Okay, so relays are, we use relays. Okay, that is one type of relays. Okay, that is one type of relay. We use relay to switch a path. Okay, to make short circuit or open circuit to a path. Okay, normally that is the purpose of relay. Okay, relay is switching a path. Okay, we use switching a path or to make open circuit or short circuit. Open circuit or short circuit. Okay, short circuit. Okay, for example, you can done mechanical relays. You can use electromagnetic things. No, so that means if you have a, movable metal plate here. Okay, so that can be moved this way and this way. Okay, and again you have a metal plate here. Okay, it is fixed. It is fixed. It cannot move. Okay, then if you place electromagnetic. Okay, electromagnetic, you already know that if you have a conductor. Okay, and if you so I have told you this. Okay, if you have a coil. Okay, conductor coil with this conductor pole. Okay, and if you give a current, if you give a voltage to this coil, it will work as a magnetic. Okay, so you can see that this plate is a metal. This plate is metal. It can move here and here, so it will become here and fix with this plate. Okay, so that means it is short circuited. It is switching. Okay, and once you disconnect this line, the electromagnetic that magnetic effect will disappear, and again this will move to that part. If you have a spring or something, okay, you can move it away. Okay, so that you can see that using this electromagnetic force. Okay, electromagnetic force, you can switch or unswitch the relay or open or short circuit. If it is, if it is touch, it is short circuit. If it is open, we can say it is open circuit. Okay, and also you can use transistor. Okay, so transistor for to so it doesn't have a moving part, so those are static relays. Okay, so you can simply use a transistor. Okay, so if you have a transistor, I already told you that in a transistor you have 3 pins. Okay, base, collector, and emitter. Okay, okay, and if you give a current to this base. Okay, okay, very small current to be this base. Okay, if you have a battery connected or something. Okay, so this path will be switch. Okay, shorter. Okay, so you can create a short circuit again. Okay, so if you remove this current, again this two terminal will be open. Okay, so again you can make a open circuit. Okay, so in that way you can make open and short circuit using relays. Okay, so there are two types of relays: mechanical relays and static relays. You should have this idea. Okay, okay, now we will stop our discussion. Okay, I think we have talked about sensors and actuators and control system controllers. Okay, so now I will give you one one exercise to do by yourself. Okay, so say that we have following uh, equipment. following equipment or item. Okay. We have a temperature sensor. Temperature sensor. Okay. So the range of the temperature sensor is, let's say that it is 0 to 45. Okay. This is the range of the sensor. Okay. And the output will be linear. Okay. It is directly mapped with the temperature. Okay. So let's say that output is a voltage, and voltage is given by, okay, T is equal to, let's say that 9 V. Okay. So this T is the temperature, and this V will be the generated voltage. For example, if you have 45 Celsius, okay, 45 Celsius, the voltage will be 45 divided by 9, that will be 5. Okay. And uh, if the voltage is 3, let's say that 25 Celsius, okay, then uh, the temperature is 25 Celsius, so voltage will be 25 by 9. Okay, you have some value. Okay, likewise, you can measure the voltage using this identity. Okay, using this identity, what is the output voltage, okay, of the sensor. Okay, so that is a sensor. Okay, and you have some actuators. Okay, you have some actuators, you have relays. Okay, and you have a air condition machine, and you have a heater. Okay, so those things you have, and also you have a Arduino controller. Okay, Arduino board. Okay, or at mega processor. Okay, and now you need to design temperature control system. Okay, temperature control system. Temperature control system. Okay, control system. We have already talked this, how to design these things. Okay, so you need to, so say that you need to control the temperature in a room or something. Okay, you need to keep the temperature between, no, you need to maintain the temperature. Okay, you need to maintain the temperature at 25 Celsius. Okay, so you need to maintain the temperature at 25 Celsius. Okay, and the room temperature can be changed between Celsius 30 to Celsius 35. Okay, the, the room temperature can change in this range. Okay, but you need to maintain it at 25. Okay, so using this item, you have to design a temperature control system. Temperature control system. Okay, system. Okay, so you have to write the algorithm. Okay, write the algorithm. So you can use, no need to use the, so you can use your own word. Okay, for the algorithm, we have done it. No, we have done some algorithms. Okay, algorithm is the set of instruction. Okay, set of instruction, I think you can remember that. Set of instruction that is given to, that should be given to the controller. Okay, so that is not in a computer programming. It should be written in a computer language to feed the to feed the controller. But at this time, you no need to use the computer language. Okay, so you can use your word. Okay, to write that algorithm. Okay, and also you have to draw the complete diagram that have the connection. We call that schematic diagram. Okay, schematic diagram we have already. So you need to show the connection between this sensors, actuators, and Arduino board. Okay, so that is the thing you have to done. Okay, please try to do this by yourself. Okay, so we will discuss this in our next class session. Okay, thank you.